Welcome, residents! I am absolutely thrilled to guide you through today's explainer on basic optics. We're doing a high-yield board review today, and our goal? Building a rock-solid mental model of focal points and conjugacy. As ophthalmologists, you can't just blindly memorize these formulas, right? You've got to master the physics behind the lenses you're prescribing in clinic every single day. We are teaching for long-term clinical mastery here, not just short-term memorization. Let's dive in.
Here's our roadmap for today. We're going to cover the Vergence formula, primary focal points, secondary focal points, conjugate points, and finally, those classic OCAP traps.
Starting right off with Section 1, the Vergence formula foundation.
Now this right here is your golden key. U plus P equals V. Object vergence plus lens power equals image vergence. I want you to think of this simple equation every single time you dial a lens into the phoropter. Because when you truly understand how light enters a lens, how it changes, and how it exits, the math just works. We're going to relentlessly connect everything back to this equation today.
Okay, moving on to Section 2, primary focal points.
So what exactly is a primary focal point? By definition, it's the specific location where an object can be placed so its light rays exit the lens with zero vergence, meaning they leave completely parallel, heading off to infinity. And here is a huge OCAP pearl, so highlight this in your minds right now. The primary focal point is fundamentally an object location.
Let's translate this clinical reasoning back to our golden equation. Since the rays are leaving parallel, our image vergence V is exactly 0. So if V is 0, U and P have to be equal but opposite in magnitude, right? Let's do some quick active recall. If you have a +3 diopter lens, what must the object vergence be? Take a second. It's got to be -3. They completely cancel each other out. That's the math in action.
Let's shift our focus to the other side of the lens system in Section 3, secondary focal points. All right, this secondary focal point. This is defined as the location where an image is formed when light rays with zero vergence, so parallel rays coming in from infinity, encounter a given lens. Now, unlike the primary point, please do not confuse this. The secondary focal point is strictly an image location. And we can easily prove this logically with our formula. Parallel rays are entering from infinity, which means our object vergence, U, is exactly 0. So our equation simplifies beautifully. 0 plus P equals V. In other words, the lens power perfectly equals the image vergence.
Now pay close attention to this classic board trap. Look at how plus and minus lenses compare. For a plus lens, your primary focal point is on the left and the secondary is on the right. But for a minus lens, it completely flips. The primary is on the right and the secondary is on the left. The primary and secondary points are always on opposite sides of a lens, but their exact positions swap depending on the lens sign. Honestly, just draw this math out on your scratch paper the absolute second you sit down for the exam.
Section 4, conjugate points explained. Let's introduce a really crucial optics buzzword here. Conjugate points. By definition, these are 2 points that are the object and image of one another. You have to know this because it is the absolute bedrock foundation for understanding reversible optical systems. Think of it like this. Point A and point B are forever linked by the lens sitting between them. Let's actually walk through the mathematical proof for this. Going forward, say we have an object sitting half a meter to the left. That gives us an object vergence U of -2. Send that through a +3 lens and your V becomes +1. So the image forms at 1 meter to the right. Those 2 points are conjugate. Now let's reverse the light. The right side is now our object at 1 meter, so U is -1. Through that exact same +3 lens, V becomes +2. And boom, the image lands perfectly back at half a meter to the left. The exact same physical locations remain conjugate, completely regardless of which direction the light is traveling. Now that we've got the definitions and the math down, Section 5, OCAP pearls and traps, let's look at how the examiners are going to try to trick you. All right, let's do a little active recall. I want you to imagine we are sitting in your oral boards right now. I look across the table and I ask you, are primary and secondary focal points conjugate to one another? I want you to pause this explainer for a second and really think about your answer. Got your answer? The answer is emphatically, absolutely no. These points are not conjugate. This right here is one of the most common misconceptions and a classic board trap. And here is exactly why they aren't conjugate. Let's look at the requirements for each. A primary focal point requires V to be 0. It sends an image way out to infinity. A secondary focal point, on the other hand, requires U to be 0. It receives an image coming in from an object at infinity. They don't map to each other. They both map to infinity, sure, but in completely opposite directions.
Okay, rapid-fire review to really consolidate this in your memory. These are your top board pearls. 1. The primary focal point is an object location. 2. The secondary focal point is an image location. 3. They are never conjugate to each other. 4. Remember that their physical positions are reversed for plus versus minus lenses. And finally, number 5, you've got to beware the anterior and posterior terminology trap.
Let's elaborate on that dreaded terminology trap, because the test writers just love to use it to confuse you. The primary point is sometimes referred to as the anterior focal point. But as this quote points out, the quote-unquote anterior focal point of a minus lens is actually located on what looks like its posterior side. It's a mess. Honestly, try to avoid using these terms in your own head, but you absolutely must be aware of them so you don't get tripped up when the OCAP throws them at you.
So I'm going to leave you with this question. When you see the phrase anterior focal point on exam day, are you going to panic and try to pull some confusing textbook diagram out of your memory, or will you fall back on the rock-solid physics of U plus P equals V? Trust the fundamental math for spherical lenses. It won't let you down. But before we go, ask yourself this. What happens to these conjugate points when we introduce astigmatism and cylinders into the mix? Well, that is a giant puzzle for our next explainer. Keep studying hard, trust your formulas, and make sure you apply these mental models in clinic this week.